Okay, so today we're going to cover two main topics, which is the first part is network topologies and technologies, and the second part is we're going to discuss the different network media. So these are the following learning outcomes that we're going to cover. Describe the primary physical networking topologies in common use. Describe primary logical networking topologies in use. Describe the major LAN networking technologies. Define the primary cables used in wired networking. And describe the characteristics of major types of fiber optic cables. So these are combined learning outcomes from units 3 and 4. So what is a topology? And the answer is, in simple terms, a topology can be defined as the shape or the layout of the network. Okay? And they say that describe the layout of the lay of the land. A network topology describes how a network is physically laid out and how signals travel from one device to another. Since the physical layout of the devices and cables doesn't describe how the signals travel from one device to another. So the topology can define physically how the network actually looks, but it may not be how it actually functions logically. And then I'll explain that later on in the later slides. So the arrangement of cabling and how cables connect one device to another in a network is considered a network's physical topology. So what you actually see with your eyes is the physical topology. So there's not something else that's called the logical topology. The path that data travels between computers on a network are considered the network's logical topology. All network designs today are based on these basic physical topologies: bus, star, ring, and point-to-point. So those are the topologies we're going to be also covering in this class. So we can see the diagram in this slide. This is the physical bus topology. Physical bus topology is the simplest and once was the most common method for connecting computers. Defined as a continuous length of cable connecting one computer to another in a daisy chain fashion. There is a limit of 30 computers per cable segment. The maximum total length of cabling is 185 meters. So this is a very outdated network topology. It has its pros and cons. Okay. Um, I think it has more disadvantages more than anything, actually. And communication is done in series, which means it only goes one direction at a time. And if a message is broadcast, it means that the message will have to pass through all of the computers on the network. Okay, so you can see some of the disadvantages. The other thing is if one termination, we call it termination points because it uses a coaxial cable. Okay, so all of the connectors here, we call them termination points. If one termination point is down, then it means the entire bus network would be affected. So you can see why this is an obsolete physical topology, is no longer widely used today. Then we have the physical star topology, and it actually looks like a star. At the center of the star has to be a special device called a switch. Okay, uses a central device, a hub or a switch to connect computers. What are the advantages of a star topology? Much faster technologies than a bus. Centralized monitoring and management of network traffic is possible, and easier network upgrades. Okay, so let me break it down. If you look at the diagram for the star topology, the first thing you can see is the switch in the center of it, which means now the data doesn't have to travel between the different computers before it reaches the destination. It means it can go directly to the destination. But also we find we find star topologies where there is a hub. Okay, so we have star topologies where there's a hub, then we have star topologies where there's a switch. The difference between the hub and the switch is that the hub is basically a connection point. It doesn't do anything more than that. But the switch is very sophisticated. It's able to manage collision detection. Okay, so whenever packets are sent at the same time, they do not collide and cause conflict. There's sort of a queue that they go into, and it sends through the one, and then once the one is finished, and then it sends through the other one. Okay, and also it's easier network upgrades, which means it's very easy to separate a problematic node without affecting the entire network, as opposed to the bus topology where if you ever separated one network, then the entire thing is affected because the termination point then has a disconnected node. Okay, so then we have extended stars. Extended stars is basically a star topology with extended capacity to add. Maybe the switch you had before only had 24 ports, and now you want to expand ports because your network is increasing in capacity. So you just get a hub or an additional hub or an additional switch, then that becomes an extended star topology. Okay, and these are the advantages. There are many advantages of physical star. There's one disadvantage. The central device represents a single point of failure. If the hub or switch fails or someone kicks the power cord out of the outlet, the entire network goes down. So similar to how the kind of problems you would typically find in a client-server based architecture network is that there's this central device which is at the core of communication. And if it goes down, then the entire network is finished. And you don't find that in the bus topology. So again, data travels in one direction. In any station, if the ring fails, data can no longer be passed along. So this is more of, I think this was supposed to be, yes, sorry, this was supposed to be the token ring, not extended star topology again. So this was supposed to be token ring. Nonetheless, the token ring topology is no different to the star topology in the way they are organized physically. Okay, so we say a ring topology is more of a logical organization. It looks physically, it looks like the star, but the way that the data is transmitted, it's through a what we call a token ring. And before each computer can communicate in the network, they have to pass around this token ring. If something's wrong with the token ring, then the network is very much affected. And this happens in a sort of like a clockwise manner. So if there's actually a breakpoint within the network, then it becomes a problem because it affects the entire network. So you can see even with the ring topology, we call it more of a logical topology. And then we have point-to-point communication. And this happens through what we call wide area network links. I think the last time in the last class we discussed what are wide area networks. They branch out between multiple countries or cities or whatever. So in under one circumstances would you find point-to-point communication, an ISP who wants their customers to connect to the internet. So they'll give you a router, and through the router, you will be linked to their WAN, okay? So it's a point-to-point communication. Or ISPs can connect to each other's WANs. So if you have, it's the same ISP, just different buildings. They're going to initiate a point-to-point connection, okay? So when we spoke about this device called a switch, and most network media can either communicate with half duplex or full duplex. Okay, so what is half duplex? Half duplex means you can send, you can receive, but you can't do both at the same time. So you can't do them in parallel. You have to do them in series. which means you're either sending at a given point in time or you're either receiving. So if you're talking about a half duplex device, that's what it means. But full duplex means you can send in both directions, and they have collision detection mechanisms in place to handle any possibilities of data collisions. We have the 802.11 standard, and that's the standard for Wi-Fi connections. And Wi-Fi connections can be broadcasted at either 2.4 gigahertz radio frequency or 5 gigahertz radio frequency. Obviously, these are two different channels. Most Wi-Fis broadcast in these two channels. So if you you might pick up that the Wi-Fi is showing twice, it's because it's two different channels. If you're really looking for faster speed, then you're going to connect to the 5 gigahertz channel. So since Wi-Fi is available to anybody who's in proximity to our building, we need to ensure that there's proper security. And one of the ways is through encryption. So you can either have an open Wi-Fi or you can have an encrypted Wi-Fi. So we encrypt it with the key, and only people with the key are able to connect. So there are different encryption standards for Wi-Fi. There's WPA, there's WPA2, and then there's WEP, which is Wired Equivalent Privacy, okay? The most, WEP is already outdated, and we've moved to WPA2. So most of the time you find on our routers and stuff like that, there will be a key at the back which tells you how you can connect to the router. So that is the Wi-Fi key, and that is, it can either be in those kind of standards, encrypted standards. So there are different technologies out there which enable us to connect to the internet. And some of these technologies you may be familiar with, such as ADSL. We're slowly phasing out ADSL and moving to fiber connections because it's more faster and it's more reliable, okay? So with ADSL, what does it stand for? Asymmetric Digital Subscriber Line. The term asymmetric is coined from the concept that there will be different speeds for uploading and downloading. So hence, it makes ADSL so affordable for the regular home. Because, I mean, if you're sitting in a home where most of the things you are doing is watching YouTube, downloading songs, downloading movies, you do not need to have a symmetric connection then, because you spend most of your time downloading than uploading. If you are paying for a symmetric connection, you're going to be paying more because you're getting equal speeds for both. Okay, so ADSL is very popular for homes because of the fact that it's asymmetric and it balances the aspects of symmetry and speed. And then in contrast, you would have symmetric connections where very high speed, or VDSL is an example of such. It comes in two forms. It can either be symmetric or asymmetric. You can see that the bandwidth it can send is up to 52 megabits per second, which is way faster than what ADSL can transmit data in. If neither DSL nor cable modem are available, satellite internet is an option. Speeds are comparable to DSL, and where cable modem was several years ago. Okay, so we also have an option of using satellite-based internet connections. So wired networking uses tangible physical media called cables, two broad categories of cables, copper wire and fiber optic. The main difference between these two are, so when it comes to fiber, the cabling standard for fiber is it transmitted signal using light. Okay, it transmitted signal using light source. When it comes to our regular Ethernet cables, it's not using light, okay? It's using some sort of what we call a broadband signal, which requires wiring, right? So we tend to say that then fiber is going to be faster because it transmits the signal using a light. We also have coaxial cables, and maybe you also may call this DSTV cables, but these are more popular in TV networks. That's why you see them on DSTV. But they can also be used for regular networking, especially in the bus topology. Olden day bus topologies made use of coaxial cables. Then we have our Ethernet standard. And when it comes to the Ethernet cables, you can have either RJ11 or RJ45. They are the ones that RJ11 connects to our phones, okay? Telephone networks or telephone cables. And then we have RJ45, which is the thicker one, which is the one that goes into our computers. So these cables can either be UTP or STP. UTP stands for unshielded twisted pair cable, and STP stands for shielded twisted pair. What is the difference between these two? Okay, Ethernet cables that have a shielded twisted pair will have higher tolerance to interference, which means the signal won't break if there's whatever radiation in the background. Okay, because what happens is wireless signals interfere with devices or interfere with data being transmitted through cables. So if you accessing the internet and then you're changing the channel on the remote, because the remote and the TV uses wireless signal to communicate, that it may interfere with your internet through the cables. Okay, so to avoid that electromagnetic interference, we put a shield between inside the cables. Okay, so this is how a fiber optic cable would look like, which you can see there's no twisted pairs wires inside. It's very hollow because it uses light to transmit the signal. Cabling plants, these look very scary. And you can see it. I mean, trying to troubleshoot this will be very time consuming, but what you see, the diagram you see on the right-hand side, we call that a distribution rack. It's used to mount our servers, our routers, our switches in a server room. So you're most likely to see cabling plants as server farms. Whatever server room you have in big companies, you're going to see cabling plants. We have the patch panel, which is a panel where after we mounted our switch or hub, we can connect to that. And then we have our patch cables, which connect to the patch panels. Horizontal versus backbone wiring. Backbone wiring is when we are connecting a distribution rack to another distribution rack. Okay, so we will be using what we call backbone cabling. So in contrast to that, horizontal wiring is when we're connecting a distribution rack to a work area. A work area is a part of the network where we find our workstations and where all our users sit and work. So there's usually going to be a main port or outlet where we connect from the distribution rack into the work area where the end users are. So wireless networking, as wireless networking has become more affordable, demand has increased. Many home users have turned to wireless networks. Wireless networks are often used with wired networks to interconnect geographically dispersed land or group of mobile users with wired service and resources on a wired LAN, sometimes referred to as hybrid networks. Even in small networks with workstations connecting to a wireless access point or a router, the access point or router usually connects to the internet via a wired connection to a cable modem. So normally you find that we have a router and there's a modem mounted on the wall, and the router is connected to the modem, and the modem is connected to the external infrastructure, which is the telephone networks. Okay, and then the router is transmitting the signals wirelessly. So although we are connecting wirelessly, but to some extent, there is going to be some wiring, especially going into the external network. So we have our local area networks, which are transmitting wireless signals in terms of wireless LAN. We have extended LANs, which use some sort of signal booster to boost the distances at which we can connect wirelessly. Internet service used to bring internet services or access to homes and businesses. And then we have mobile computing, which that is also an example of wireless networking because computers are not, mobile devices are not wired. Instead, they use waves or microwaves rather, instead of radio waves. Radio waves, the difference between microwaves and radio waves is that radio waves cannot penetrate, it's the range at which they transmit, and radio waves cannot penetrate a certain layer of, I think we call it the lithosphere with all the gases, so it cannot penetrate that layer. So what happens is then you keep the waves of it very short, and its frequency is also very short. Most radio wave technology includes radios. Radios, that's why you can pick it up only when you next to a particular radio station, and also Bluetooth technology broadcasts in radio waves, infrared technology. So that's why there's so short distance. But our phones, they're also wireless, using technologies such as 4G, 3G, 5G. And how are they achieving this? They're achieving this through microwaves. So because microwaves have to connect to the satellite, they have to be able to penetrate every layer of the atmosphere. Okay, so that is unit 3 and 4 revision. Okay, so do you have any questions regarding these concepts?
No, sir, no questions.
Okay, so are you ready for the exam?
Yes, sir.
Okay,